So this is going to be a quick lecture on prime numbers. First, I want to remind you what the natural numbers are. So the natural numbers are just the numbers 1, 2, 3, 4, etc. And we go on infinitely. So these are just the counting numbers, the numbers you would use to count. And notice that they're all positive and there's no zero. So these are the natural numbers. So by divisor, so we basically mean a number that divides another number with no remainder. So for example, 9 is a divisor of the number 27, since 27 divided by 9 is equal to 3, and there's no remainder. Okay, in other words, 27 can be written as 9 times 3. So 9 is a factor of 27. The next thing I want to talk about is prime numbers. So what is a prime number? A prime number is a natural number greater than 1 that has exactly 2 natural number divisors, 1 and itself. So here are some examples of prime numbers. So I'm not going to include 1 because remember it has to be a natural number greater than 1. So 2 is the smallest prime number. It's the only even prime number. Then we have 3, 5, 7, 11, 13, 17, 19, and we can keep going. The list actually is an infinite list. There's infinitely many primes. You'll see when you read the lecture notes. So here's a quick example. Is the number 6 prime? So in this case, we can see 6 is divisible by 1. It's also divisible by 2, 3, and 6. So no, we would say actually it's composite. Is 23 prime? 23, if you go through all the numbers, you're going to find 23 is not divisible by anything other than 1 and 23. So yes, this is prime. And what about 51? Is 51 prime? It kind of looks prime at first. But one thing you'll notice is it is divisible by 3. So 3 times 17 is 51. So it's also divisible by 17. There aren't any other numbers it's divisible by, but that's more than just 2. So this is not prime. It's composite also. One trick I wanted to tell you was that one of the reasons I knew that 51 was divisible by 3, the reason is that if I add 5 plus 1, I get 6, and 6 is divisible by 3. And if the sum of the digits in a number, if the sum is divisible by 3, then that number is divisible by 3. So as you work through the homework, there will be some exercises where you take a look at some divisibility rules. So I just wanted to say a little bit about them. So for example, we can tell that 13,140 is divisible by 2 because it's an even number. Okay, it ends in an even number. It's an even number. We also can tell, there's also a rule that tells us that this number is divisible by 3. And what you do is you add the digits, 1 plus 3 plus 1 plus 4. So that gives me 9. If the sum of the digits is divisible by 3, then this number is divisible by 3. So this is also divisible by 3. There's also a rule that says that if the last 2 digits are divisible by 4, then the number is divisible by 4. So since 40 is divisible by 4. We get 40 minus 4 is 40 divided by 4 is 10, so there's no remainder. So this is also divisible by 4. Another rule states that if a number ends in 0 or 5, then it is divisible by 5. So we know that this number is divisible by 5 as well. And yet another rule states that if a number is divisible by 2 and it's divisible by 3, it's divisible by 6. So since this number is divisible by 2 and 3, it's also divisible by 6. You will also encounter another rule that says if the last 3 digits of a number are divisible by 8, then the number is divisible by 8. So in this case, this number, unfortunately, is not divisible by 8. However, we do have a rule that says that if the sum of the digits, which we already calculated to be 9, is divisible by 9, then the number is divisible by 9. So this number is divisible by 9. Yet another rule tells us that if the last digit is 0, the number is divisible by 10. So there are more rules. I'm not going to list them all, but there are divisibility rules that can help us tell which numbers a given number is divisible by. Okay, so let's give the prime factorization of 1050. The first thing I usually do is I use the divisibility rules and I just I keep dividing the number. So I start with 1050 and I can see that it's even, so I'm going to divide this by 2. So 2 goes into 10 5 times. I multiply, I subtract, and I bring down. 2 goes into 5 twice. Multiply, subtract, bring down, and 2 goes into 10 5 times. So I can see that 1050 is equal to 2 times 525. So I'm just going to write the 2 here and the 525 here. Now I can see that 525 is divisible by 5 because it ends in 5. So I'm going to divide 525 by 5. So I subtract and I bring down the 2. 5 doesn't go into 2, so I subtract and I bring down. 5 goes into 25 5 times. So I can see that 525 can be broken down into 5 and 105. Okay. So my main goal with prime factorization is I'm just trying to break this number down into prime factors. 105. Notice that 1 plus 0 plus 5 is 6. So since 6 is divisible by 3, we know that 105 is divisible by 3. So I'm just going to do that, and I'm going to divide that number by 5, or 3. Okay, and so now I have this number breaks down is 3 times 35. And 35 I know is 5 times 7. So basically at this point I can see that 1050 is equal to 3 times, 2 times 5 times 5 times 7. So the prime factorization, these are all prime numbers. So we can write the prime factorization is 2, you can use a dot or an X, 2 times 3 times 5 squared times 7. So this would be the prime factorization of 1050.